don't get it mixed up. Reference angle and angle of inclination is not the same thing. Now, let's say we have the coordinate system. Now, this coordinate system, we have the y-axis, the x-axis, the y-axis, and the x-axis. Now, this is the negative x-axis, negative y-axis, positive x-axis, and positive y-axis. Now, we have the first quadrant. This is the first quadrant. We have the second quadrant. We have the third quadrant. Then we have the fourth quadrant. Now, the question is, what is the angle of inclination? Let's give an example. Now, let's say we have the coordinate system again, and a vector travels along the x-axis and is inclined at a particular angle, theta, in degree. All right, now a vector, maybe a force, travels along the x-axis at an angle theta. Now, the angle of inclination is simply the angle that is formed by a line. You notice this is a line or a plane. The angle that is formed by a line or a plane to the horizontal. The angle that is formed by a line or a plane from or to the horizontal. That is what is called the angle of inclination. Now, what of the reference angle? Let's say you are solving problem in physics that involve two-dimensional space questions, or questions that involve 2D in physics, vectors, or resolution of vectors, 2D vectors. They can be more than a vector. A single vector can be splintered into 3 or 4 or more vectors. But if you put those vectors together, they will still give the same effect in magnitude and direction from the original vector. But that one is under 2D, resolution of 2D vectors. Now, under here, if we have this angle of inclination, for instance, the theta 1, which is the angle of inclination, is the same thing as the reference angle. Because any angle that is found here at the first quadrant, the way to get it is that it's the same thing with the angle of reference. Angle of reference is the same thing with the angle of inclination. Let me give you an example. Let's say we have this, and then a force travels in this direction. A vector can be a force, can be velocity, can be acceleration, any of those. Now, 45 degrees. Now, remember that the reference angle here will be equals to 45 degrees. Let's say we have another vector, and then the vector travels along the x-axis, let's say with the angle inclined at 80 degrees. Now, the reference angle here, the reference angle is the same as 80 degrees, because the angle of inclination and the reference angle is the same thing at the first quadrant. And let's go to the second quadrant. At the second quadrant, which is theta 2, for the second quadrant now, if you go from here is 0 degree. When you get here, you have 90 degree. From here is 180. From here is 270. And then here can also be called 360 degree, making a complete cycle. Now, for the angle that is inclined at the second quadrant, for instance, let me give you an example. For the angle that is inclined at the second quadrant, you need to know that it is the reference angle will now become 180 minus the theta 2. 180 minus theta 2. The theta 2, or angle of inclination, will be equal to the reference angle, that is 180 minus the theta 2. Let me show you what I mean. Now, when we have this, this illustration usually gives students difficulty to find the angle of reference angle while solving for 2D, resolution of 2D vectors. Now, let's say an angle is inclined here, all right, and inclined towards the negative x-axis. all right, at an angle 35 degree. Now, the reference angle you can use, if you use minus 35 degree, you can get your answer. But the major thing to use is simply use this. Say that theta 2, which is equals to the reference angle, which is 180 minus the theta 2. Now, 180 minus 35. 180 minus 35 degree, if you want to, will give me 45 degree. So the reference angle here is, 145 degree. So the reference angle here is 145 degree. That means from here to this place totals 145 degree. Unless you can have 20 degree, you can have 30 degree. Just follow the procedure, you'll get your answer. All right, let's go to the next one. The next one is that when we have an angle at the third quadrant. For the third quadrant, which is theta 3, is equals to the reference angle, and the reference angle is equals to 180 plus theta 3. That's how we get the angle that is at the third quadrant. Now, let's have an example. Let's say an angle is suspended here towards the negative x-axis, just like this, and then it is, let's say, angle 30 degree. All right, 30 degree. Now, this is 30 degree. My theta 3 is equals to the reference angle, which is equals to 180 plus theta 3. And this is simply 180 plus 30 degree. When I've done that, my reference angle will become, if I add 180, 20 here, to become 210. The reference angle will become 210 degree. That means traveling from here to this place is simply 210 degree. You can have 45, just follow the same procedure. You can have any angle, follow the same procedure, you will get the reference angle. Let's say for the last one, which is the fourth quadrant. For the fourth quadrant, which is, let's use red pen, okay? For the fourth quadrant, theta 4 is simply equals to reference angle, which you are going to say 360 minus theta 4. That's how to get the angle there. 360 minus theta 4. You need to follow this procedure. All right, so arrive at your reference angle, 360 minus theta 4. Now, let's say we have a question, and an angle is suspended here at an angle 65 degree. Now, remember that my theta 4, the reference angle is equals to, or the angle of inclination, which is equals to reference angle, is 360 minus theta 4, the fourth quadrant, which is 360 minus 65. That will give me, this is 300 minus 5, that will give me 295. So 295 degree. So from here, all through to this place will give me 295 degree. And you can solve for anyone. Let me give you a question. Find the angle of inclination of the following forces. This is force 1. This is 70 degree. This is force 2. This is 40 degree. This is force 3. This is 20 degree. This is force 4. This is F3. And this is F4. And this is 35 degree. Can you help me find the angle of inclination and find the reference angle, and drop your answer in the comment section? I'll be glad to see that. Thank you very much for watching. Please have a great day.